This is a lecture on how to answer titration questions for the Cambridge International AS and A-Level Chemistry, Syllabus Code 9701. We'll be using the question 1 from paper 31 of the May-June 2021 series. It's a redox titration, however, almost all titrations have the same steps and procedures, so this would be a good example. Before starting any practical work for any question on paper 3, you should always read the full procedures first to make sure that you don't miss anything. So here it reads, iron 2 sulfate crystals contain water of crystallization. You will carry out a titration to determine the value of X in the formula, where X is an integer. A solution containing a known mass of the crystals will be titrated with acidified aqueous potassium manganate 7 of known concentration. The chemical equation for the reaction is almost always given, so here it is. And then the materials are given. So here it says Fa1 contains 26.52 grams per decimeter cubed of hydrated iron 2 sulfate. Fa2 is 0.02 molar of potassium manganate 7. And Fa3 is dilute sulfuric acid. The methods are as follows. Fill the burette with Fa2, pipette 25 centimeter cubed of Fa1 into a conical flask. Use the 25 centimeter cubed measuring cylinder to transfer 25 centimeters cubed of Fa3 into the same conical flask. We will then carry out a rep titration and then accurate titrations, which is typical of almost all questions. This is a redox titration, so you don't want to spend more than 45 minutes on any question. Question 1 is typically the longest out of the 2 or 3 questions that you'll have. So the experiment should spend about 25 to 30 minutes, and then the questions and the table 15 to 20 minutes. So here are some of the materials that we're going to use. We're going to obviously use Fa1, Fa2, and Fa3. To fill the burette, we're going to need a burette and a funnel. To pipette 25 centimeters cubed of Fa1 into a conical flask, we're going to need a volumetric pipette filler, beaker, and conical flask. And then to use the 25 centimeter cubed measuring cylinder to transfer 25 centimeters cubed of Fa3 into the conical flask, we're going to need a graduated cylinder, funnel, and plastic pipette. Again, here the materials just laid out. So these are plastic funnels, a plastic pipette, graduated cylinder, beaker, the 3 materials, Fa3, 2, and 1. On the day of the exam, these are always given in beakers rather than volumetric flasks, so just note that, and they're always going to be labeled. The conical flask, volumetric pipette and pipette filler, the burette, and then finally paper towels. Paper towels, though they're not listed, are always great to have in any experiment in chemistry. So the first step, it says to fill the burette with Fa2. We're going to need the funnel and then the burette. Make sure that the burette is both clean and closed. You know it's closed if the stopcock is horizontal or perpendicular to the burette. If it's vertical, then you know it's open. Horizontal, it's closed. So you're going to put this plastic funnel into the top of the burette and then pour in the solution. Remember to hang it onto this burette clamp. So burette clamps, the way that they work is that you put your fingers in these little holsters over here. You push down, and that will create a little opening that you could put the burette in, and then you release to make it clamp onto the burette. You could adjust the height either by unscrewing this thing over here and moving it down the ring stand, or you can just squeeze these, move the burette physically down, and then release. When filling the burette, you need to make sure that this area at the bottom has no air. If it has air, just open the burette slightly over the sink to purge it of any air. This process is known as purging the burette. In the burette, you need to make sure that there's only Fa2 or the solution that you need in the burette. If there's any air bubbles, you can flick them out using your fingers. However, if they're still there, you're going to need to pour all the solution back into the beaker and then fill it again with no air bubbles. The next step says to pipette 25 centimeters cubed of Fa1 into a conical flask. So in this beaker, we have Fa1, this beaker over here. So we're going to attach the pipette filler to the volumetric pipette by just placing it on top. And then you're going to see this little wheel. You're going to roll that to suck up Fa1 from the beaker. You want to go until you reach this line that is given on the pipette. And then once you get it, you're gonna keep your finger on that wheel, not move it, and transfer it over to the conical flask, which is what it says in the instructions. Place it into the conical flask and then unscrew that wheel to release the substance, which is Fa1. At the end, you're going to have a drop of liquid left at the tip of the volumetric pipette, which is meant to be there, so don't try and force it out. Just take a piece of paper towel and dab it on the end to release that bit of liquid. The next step says to use the 25 centimeter cubed measuring cylinder to transfer 25 centimeters cubed of Fa3 into the same conical flask. Here's a 50 centimeter cubed measuring cylinder, or graduated cylinder, because we didn't have a 25 centimeter cube cylinder, but it's the same thing, same deal. Never transfer substance into a graduated cylinder directly. You always need to use a funnel just to make sure that you don't get anything spilled. So you're going to take your substance, this is Fa3 that's in this container. You're going to pour it until you get to 25 centimeters cubed. Okay. So how do you know what 25 centimeters cubed is? Well, whenever you're reading volumes, always make sure that you're looking at the meniscus. So fluids are weird in that when they're in a measuring cylinder, if the solution contains water, which almost all solutions do, they're going to form a little meniscus or divot at the bottom. Whenever you're measuring the volume, don't measure it from this top part. You always have to measure it at the bottom of the meniscus. So here the volume would be 19 centimeters cubed. It wouldn't be 19.3 centimeters cubed. If your meniscus is a little bit above or below the desired volume, in this case 25 centimeters cubed, you can use the plastic pipette to add or subtract a small amount of the volume to get the meniscus at 25 centimeters cubed exactly. And then it says to pour this into the same conical flask. So this has Fa1 already in it. We're just going to pour it into the same conical flask. Okay, the next step is to carry out a rough titration. So a rough titration gives us an approximate value for the amount of Fa2 we're going to need to add to reach the endpoint. This is because whenever we're doing a titration, the first time we don't know if we're going to need to add 1 centimeters cubed of Fa2 or 100 centimeters cubed of Fa2. So this will give us an approximate value, which then we'll use later in our more accurate titrations, which you'll see down the line. Before you begin titrations, you need to have this little planning sheet. So on the practical, you're going to be given a blank sheet that is not scored by the examiner. This is meant for your own use and planning. It's very smart whenever you have titrations to label it as such, with ref titration, titration 1, 2, and 3, each having initial, final, and titer. Titer is the solution in the burette, in this case, the purple Fa2, and the analyte is the solution in the conical flask, which is Fa1 and Fa3. So just for reference and definition's sake. So always make sure that you have this because whenever you're doing the experiment, you're going to be all over the place. So it's just better to have it planned out before you continue. So we're going to need to take our initial burette reading. So how do you measure burette readings or volume readings in Cambridge? So burette readings are always given to 2 decimal places and the units are centimeters cubed. If the meniscus falls directly on the line, then the second decimal is 0, or the final number is 0 in the reading. So here the reading would be 19.00. However, if the meniscus falls anywhere between the 2 lines, the second decimal or the last number is 5. So here would be 21.5. Even if it's almost at 22, it's still 21.5. In Cambridge, if the number does not end, if your reading does not end in 5 or 0, you're not going to get the points. It has to end in 5 or 0. And remember, 2 decimal points and measured in centimeters cubed. So here, we're looking at the meniscus, at the bottom of the meniscus. It's between 2.9 and 3, so it's going to end in 5. So the reading is 2.95 centimeters cubed. And then you can write that on your blank sheet Initial 2.9 centimeters cubed. 2.95, sorry, centimeters cubed. Now we can begin the first titration. So before you begin the titration, make sure that this part of the burette, this capsule, is within the conical flask, just to make sure that you don't spill anything. You have a piece of paper, a piece of white paper towel or a white tile underneath the conical flask so you can know any color change. And you have your two hands, obviously, and some distilled water. So before you begin, you can rinse the sides of the conical flask with distilled water just to make sure all solutions are in there, and then you can begin the titration. Gradually opening and closing the stopcock until you see a color change. Remember to continually add distilled water to the sides of the conical flask to make sure every bit of Fa2 added is actually going into the solution. As you add more, you're going to see that the color, the purple pinkish color, persists for longer. That's when you know that you can slow down a little bit as you're reaching the endpoint. So at this point, you see that we have a pinkish color. So that means that we added the amount of Fa2 in the solution is more because the purple color is overpowering that clear color that we had at the beginning. So right now we added more than we needed, but again, this is the rough titration, so that doesn't really matter. It just gives us like a rough estimate of the amount that we need. Remember to always swirl as well during the titrations. So then you need to read the final burette reading. So as you can see here, it's between 27.4 and 27.5. Even though it's closer to 27.4, because it's in between the two lines, it's going to end in 5. So our reading is 27.45 centimeters cubed. And then you can note that on the blank sheet. And then from there, you can calculate the titer added or the amount of Fa2 added, which would be your final minus your initial. So we got 24.50 centimeters cubed for our rough titration. So then from there, we can write that on our paper. So it says, carry out a rough titration and record your burette readings in the space below. For rough titrations, you need to note the initial, the final, and the amount added. So you're just going to take that from your sheet, which is very convenient. You just write initial 2.95 centimeters cubed, final 27.45 centimeters cubed, and then the rough titer added. Remember, 2 decimal places, centimeters cubed ends in 0 or 5. That's like the most important parts of reading volumes and calculations with volumes. So before you continue the titration, you have to use that same conical flask because you're going to pour out and clean this conical flask. So how do you do that? You take the conical flask, pour it out into the sink, then using distilled water, clean the sides of the flask thoroughly, rinse it around to make sure that you get all of the particles and molecules of Fa1, 2, and 3, and then do that 2 more times. Now this is clean and can be used again for the future titrations. Now, you may have to refill your burette again because you might not have enough, so follow the same steps. Make sure that the burette is closed, take the funnel, place it at the top, fill it with Fa2, and then you're good to go. So now we have to record the initial for our first accurate titration. So this one is 2.40 because it's directly on the line, the bottom of the meniscus, 2.40 centimeters cubed. And then we can obviously record that in our titration 1 initial. So this is where the rough titration really comes into play and really helps us out because honestly, titrating takes a lot of time if you don't know when it's going to end. So we know that the amount that we're going to have to add is around 24.50, maybe a little bit less. So we're going to slow our titration after we added already 20 centimeters cubed. So we're going to slow down around 22.40 centimeters cubed. So this is how we can begin. You can just go ahead and add all of that down. This is not sped up. Just add it until you reach around 20 to 22 centimeters cubed. Again, this is all thanks to the rough titration and that we know roughly how much we need to add before the color change starts to begin. So after you've done that, you're going to have to go very slowly, drop by drop, and maintain a steady stream. So you slowly open the stopcock so that you get a drop by drop stream. Be very careful because sometimes they go very quickly. So you just got to keep a steady hand on that. And remember to swirl constantly. And then if anything gets on the rim of the conical flask, you can obviously use distilled water to wash that off. Remember, we're being a lot slower and going drop by drop because these are the accurate titrations and will determine our calculations in part B of the question. As you can see, I got a drop on the side of the conical flask, so you can just rinse that with distilled water. The endpoint is always when it's kind of a medium between the initial color and the final color. So we know the final color is obviously this purplish color, and the initial color is a clear color. So we're looking for like a pinkish medium where the colors are equal in weight. It's a little bit subjective, so just try and use your best. But honestly, when you're doing this for such a long time and titrating, you just get the sense of like, okay, the color has definitely changed. So as you can see, we're seeing hints of this pinkish color come into play. And then finally, it turned a darker color, which is a signal that the titration has reached its endpoint. So from there, you are going to record the final using the same thing, the meniscus, two decimal places, ends in 0 or 5, and centimeters cubed. So here we got the final as 26.75 centimeters cubed. And then the titer, or FA2, added. You subtract the final from the initial, and then you get that value here, 24.35 centimeters cubed. Now we will continue with titration 2. So between titration 1 and titration 2, again, you have to clean that conical flask with distilled water 3 times. This is our titration 2. So our initial was 1.50, the bottom of the meniscus lies directly on the 1.5 line. Two decimal places ends in 0 because it lies directly on the line and is in centimeters cubed. You could write that down on your blank sheet. And again, because of our rough titration, we know we have to slow down after we add around 20 centimeters cubed. So we can slow down after we're about 21.50 centimeters cubed. So again, we're just going to add it pretty quickly because we know the endpoint's not that close. And then when we get to 21.50 centimeters cubed, we'll slow down and go drop by drop. Okay, so now we're going to go drop by drop, slowly. Now you can see the color starting to persist, and we're approaching the endpoint. When that color change is permanent for about 30 seconds, then you know that you've reached the endpoint for sure. And now we reached that pinkish color. So that was certainly our endpoint there. Then we have to record the final burette reading. So this is at 25.70 because it lies directly on the 0.7 line. We're going to end in 0, obviously, two decimal places, and measured in centimeters cubed. You can write that down on your final, and then calculate the amount of titer or FA2 added by subtracting the final from the initial. Or sorry, the initial from the final. And that will give us 24.20 centimeters cubed. Before we end titrating, we must obtain concordant values. So what exactly are concordant values? Concordant values are a maximum of 0.10 centimeters cubed apart in volume. So whenever you're finding concordant values, ignore the rough titration. The rough titration you'll never use again in the question. So you're only focusing on titration 1 and titration 2 because there are what we call accurate or fine titrations. Are titration 1 and titration 2 concordant? No, because the volume added differs by 0.15, which is greater than the required 0.10. So that's how we know we must do a titration 3 for accuracy purpose. So we're going to do the same step. The bottom of the meniscus here lies in between 0.1 and 0.2. So we are going to mark that as 0.15 because it lies in between the two lines. 2 decimal places and measured in centimeters cubed. Again, remember before continuing, you have to clean out the conical flask and add more of FA1 and FA3 to the flask. So we're going to write this 0.15 centimeters cubed in our titration 3 initial volume. And we know that we have to slow down after around 20 centimeters cubed thanks to our rough titration. And that will be around 20.15 centimeters cubed. When it shows that on the burette, we'll slow down and go drop by drop. So this is us adding it very quickly. As you can see, you're just looking for when it reaches around 20. And then you can turn the stopcock to stop the flow. So after we reach 20, we can start going drop by drop. That was not very drop by drop, but now we are, okay. Again, remember to use distilled water to make sure all of Fa2 that is added into the solution, not just onto the walls of the flask. Stirring constantly. I'm looking for at least 30-second color change. So now that pinkish color is again starting to appear, so we know the endpoint is near and we're going to go very slow. Again, the slower you go, the better it will benefit you because then you don't have to do more titrations and you're more likely to get concordant values. So don't rush because in the end, you're just going to waste more time. Okay, there you go. The pink value is, or sorry, the pink color is there. And now we have to find the final burette value. So we're going to look at the bottom of the meniscus, which is at 24.35 because it lies in between 24.3 and 24.4. We're going to have the measurement end in 5. And 2 decimal places, centimeters cubed. You can record that on your titration number 3, and then calculate the titer or amount of Fa2 added by subtracting the initial from the final, 24.20 centimeters cubed. Thankfully here, we got 2 concordant values, which is perfect. They're the exact same. Again, concordant values have a maximum difference of 0.1. Ours has a maximum difference of 0, so that's perfect. After titration 3, if you do not have concordant values, you must stop. Because at this point in time, you've probably spent at least 25 minutes doing these titrations, cleaning the flask, filling the burette, doing it over and over again. So you must stop because you're going to be wasting too much time. At that point, for titration 3, if you don't have concordant values, you must create fake values for the initial burette reading, the final burette reading, such that the calculated value of the titer or Fa2 added is concordant with either titration 1 or titration 2. So let's just say that I got 24.50. I will make up values for the initial and final so that when I subtract them, I get 24.20 or 24.35 and make up fake concordant values. This is because accuracy marks are only worth 3 marks in this question. So it's better to sacrifice these 3 marks than sacrifice time because you still have questions 2 and 3 to complete and 37 more marks to gain. So from here, you're done with your accurate titrations. Now you can begin with your table. So as you can see here, it says, make any recorded results, show the accuracy of your practical work, and then it says record in a suitable form below all your burette readings and the volume of Fa2 added in each accurate titration. So we're going to ignore the rough titration because it only says each accurate titration. Whenever you have titrations, this will always be your table. So you should try and memorize this, practice creating it very quickly so you can just do it on the test when you have the titration. So you have titration 1, 2, and 3, and then initial burette reading / the units, which is always centimeters cubed, final burette reading / the units, centimeters cubed, and then titer or FA2 added / centimeters cubed. Then you're going to add a final row that says best titrations. Thankfully, because we have our planning sheet, we can easily just put in these values in like a matter of seconds and not have to scramble around our paper trying to find where we wrote the values. And then for this best titrations, make sure that you mark the ones that are concordant. So here, these are 2 concordant ones, so we're going to check them off so that the examiner knows this is what we're going to be using in our calculations. Remember, before you move on, just to make sure that every single volume that you put in here has 2 decimal places, ends in 0 or ends in 5, and that you have the units on the side here. If you don't, you're sacrificing a lot of marks that are very easy to gain. And then after that, the first question is always, from your accurate titration results, obtain a suitable value to be used in your calculations. Show clearly how you obtain this value. So for that, you're going to take your 2 titrations that you checked marked. You're going to write down the titer added. So we're going to write down titration 2, 24.20 centimeters cubed, titration 3, 24.20 centimeters cubed. So the examiner knows that you're selecting the 2 concordant titrations, which is what you must do. From there, you're going to find the mean titer. So you're going to add up the 2 and divide them by 2, which is obviously going to give us the same value of 24.20. When you're doing this, remember to use only the concordant ones. We're not going to use titration 1 because that's not concordant with our other 2. This is the value now that we're going to use for all of our calculations in part C. So just to recap, these are where you can gain your 7 and 8 marks from this question, which is almost 25% of the paper. So the first mark is evidence and calculation of rough titration. So you must write down the initial, final, and rough titer. If you do not have this working, you will not get the point. For the table, 1 point comes from the headings and the units, so you must have these headings and you must have these units. You get another point for accurate burette readings to the 0.05 centimeter cubed. So if you end in a 1, 2, 3, 4, 6, 7, 8, 9, you will not get these points. You have to end your readings in 0 and 5 and have 2 decimal places. You get another mark for having concordant values. Even if they're made up, you still get a mark for having them. So you might as well, at the end, if you titration 3, like I said before, if you don't have concordant values, just make them up because you could still get points from that. And then the final points come from the selection of 2 titrations that are no more than 0.20 centimeters cubed apart. Thankfully, ours was 0. Again, if you don't have concordant values, you must make them up. And then the final point comes from the correct mean calculation of concordant values. These are the image sources. Thank you.